Assalamu alaikum, dear students. Today in this lecture, we will be discussing and starting relations and functions for class 12. Earlier, we have gone through sets, relations, and functions in class 11th, and some of the main concepts we have discussed there. For if you have not gone through the basic concepts of this set theory and the relations and functions, you may please visit our previous videos, and then after you see this video in order to have a clear understanding. So in the previous videos, we have discussed what is a set, what are operations on sets, and among those operations, there is an operation that's cross product. And with the help of cross product, we can cook up the concept of the relations and functions. So in this lecture, we will be discussing now the types of the relations. So what are different types of the relations? Let's take it here. One type of the relations is called as the empty relation. What is that? A relation is said to be an empty relation if no element of A is related to any element of A. That is, R is equal to Fi. That means this relation is a null set. That means there is no element in this that is contained in A cross A. Okay. And next is a universal relation. That's totally opposed to this. A relation is said to be a universal relation if each element of A is related to every element of A. That's all. That's this relation R is equal to whole cross product of A cross A. These two relations are collectively called as trivial relations. Okay, these are called trivial relations. Now let's illustrate this with the help of an example in order to make it clear in understanding. For example, we have a boys' school, and in the boys' school, the students, let's define a relationship among the students as A is sister of B. For example, we take the ordered pair. So we take two students and say A is sister of B. But the relation is defined in among the boys of a school. So such a type of relation does not contain any element because there is no student who is a sister of any other student. So such a type of relation is an empty relation. Okay. Now let's define one more relation there. For example, we take two students and we define a relation like this. R dash is equal to AB, while the difference between the heights of A and B is less than 3 meters. We take at random two students and we define a relation like this, that these two students will be having a difference of less than 3 meters height. So if we take any two students at random and if we measure their heights, naturally the difference may not be equal to or may not exceed 3 meters, because 3 meters is a very huge quantity. So every student will be related to every student. So such a type of relation is, it contains every student, it contains every two students of the school. So such a type of relation is a universal relation. We have more types of the relations. For example, we have a reflexive relation. What is that? A reflexive relation is a reflexive relation if every element is related to itself in the relation. For all, A belongs to A. I hope you got it. That means this is an element and it is related to itself. Every element is related to itself. Such a type of relation is called as reflexive. That means it gets reflected. Okay. Symmetric relation. A relation is said to be symmetric if A1 is related to A2 in R, This implies that A2 is related to A1. Okay, for all A1, A2 belongs to A. It is the transitive relation. A relation is said to be a transitive relation if A1 is related to A2. This belonging means they are related to. A2 is related to A3. These two should imply that A1 is related to A3. If such a thing happens, we say that the relation is a transitive relation. Okay, that means it gets transited. Uh, it takes a jump from first to third. Okay. Next one is the concept of the equivalence relation, a relation that's reflexive, symmetric, and transitive as well. That means it satisfies all the three types of the properties of being a reflexive, symmetric, and transitive. Such a type of relation is called as equivalence relation. We can understand these types of the relations with the help of these examples given here. For example, in this example number second, we define a relation of for the set of triangles in the plan R, a relation in these triangles given by T1, T2, where T1 is congruent to T2. We have to show that this R is an equivalence relation. You see, its T1 is congruent to T2. So if any two triangles are congruent, you know the criterion for the congruence. There are different criteria for congruence of the triangles. So if T1 is congruent to T2, you know that every triangle is congruent to itself, means it is reflexive. If triangle 1 is congruent to triangle T2, that means T2 is also congruent to T1. Yes, that is symmetric. If one triangle is congruent to second triangle, and this second triangle is congruent to third triangle, this simply means that first triangle and third triangle are also congruent. Okay, so this type of relation is an equivalence relation. I hope that you got the concept of the reflexive, symmetric, and transitive in this example as well. If you have any questions regarding the types of the relations, you can ask in the comment section. I will be more than happy to answer your queries. Thank you for joining the class. Thank you once again.